Hi everyone, Miss Barker here. We're going to start this week working on some more fraction learning targets. Our learning target for today is we will add and subtract fractions with common denominators. Our first problem we're going to practice on today is right on the screen, 3/7 plus 2/7. So again, you know that the denominators, these two fractions are the same. This makes our addition a little bit easier. So when you have common denominators, all you need to do is to add your numerators. And then if that is not, your answer or your sum is not an improper fraction, you just leave your denominator the same. So we're going to do this right here. We're going to add 3 plus 2 is 5. And our denominator, sevenths stays the same. So our sum of 3/7 and 2/7 is 5/7. Right underneath here, I just drew a couple of rectangles so we could do a little modeling of this addition. Um, Practicing this when we have common denominators will make our addition and subtraction modeling with uncommon denominators a little bit easier. So real quick, I'm just going to partition my two fraction bars into sevenths so we can see a visual model of this happening. Okay, so I have sevenths and sevenths. So the first thing I'm going to model is 3/7. 1, 2, 3/7, coloring in 3 of those 1/7 pieces. And then we're going to be adding that to 2/7. And now I do not believe that this matters, at least in the way that I see this and like to use fraction modeling. If you were to shade in any of these sevenths, two of them, that would be okay. But I think the easiest way to do this is to add, is to show kind of a continuation of those sevenths. So adding 3/7 and then two more sevenths onto that. And over here, this is going to be where our sum goes. Let me real quick partition this into sevenths. Okay. And 3 plus 2, again, we have 5 of those 1/7 pieces. Okay, and now here's our next problem in practicing addition with common denominators. But this is kind of a special case. This is going to be addition when we have a sum greater than one whole. And I'm hoping that you remember back to last week when you were practicing improper fractions to mixed numbers or mixed numbers to improper fractions. That will help us out on this problem. I've also included some fraction bars where we can show this as a model. So let's just do the modeling first, and then we'll do our sum up here as well. Okay, first thing I'm going to do, I am going to represent 8/12 on this fraction bar, and then we'll do 7/12 on this fraction bar. Oops, sorry about that. My marker kind of messed up. Okay, so I'm going to start by partitioning this into twelfths. You guys are going to be doing this on your independent practice with the drawing tools, and I know it is not super easy, but I know that you've also been working on this kind of stuff with the Google Drawings with Miss Rotier this year. So try and use that, at least give it a shot when you do that. Otherwise, you can just use the kind of the highlighting or text tools to help you too. Okay, first I'm going to start by partitioning my first fraction bar into twelfths. So I'm going to start by doing thirds first, and I'm going to kind of do that into sixths. And then if I divide each one of those into 2, then I should have my twelfths. Looks good. Okay, now do you notice how my fraction model is not perfect? That is okay. This is just so we can get a visual model of what's going on when we do that addition. I'm going to do the same thing down here. I'm going to do thirds first, then break those thirds in half, creating sixths. And then if I break one of those six, each one of those six into half or into two pieces, now I have twelfths again. Okay, now I'm going to use my red marker to model this addition. So first I'm going to shade 8/12. 1, 2, 3, 4, 5, 6, 7, 8. There should be 4 left over. That tells us we partitioned it correctly. And then I'm going to add 7 onto that. Now, what you're going to notice, if we go and do the same kind of modeling we did on the last one and model on the outside of that first 8 for the next one, and I try and do 1, 2, 3, 4, 5, I am going to have to add on 2 more twelfths to that to hit my 7/12. Now, when we go to put this in our answer, and you should see this up here when we are doing just straight up 8 plus 7, it's going to give us 15/12. That means that if we shade in this whole fraction bar of twelfths, this is only going to give us 12/12, meaning that our answer, our sum, is going to be more than 1 whole, or an improper fraction. From last week, you could do this two ways to decide what our mixed number answer is. You could either use this as our model and then add in our twelfths down here. So we would have 3/12 left over. And then we know that this 12/12 is equal to 1 whole. So our answer would be 1 and 3/12. Or hopefully you're seeing right here, you can simplify that and get the whole number 1 and 1/4. Or you could do like we did last week, practicing this without doing the modeling. You're going to divide your numerator by the denominator. And I know that 12 goes into 15 one time. And that is going to leave us with that 3 as our numerator and 12 as our denominator, 3/12 left over. And then we would go back and do that same thing with the simplifying to get our answer of 1 and 1/4. Okay, now this is the last problem we're going to practice this with today. Same concept, except for we're going to be doing subtraction with common denominators. So just like you add across your numerators and keep your denominator the same, you do the same thing with subtraction. And I actually put these fraction models down here, but I don't think we're going to use them because we've already done 2 of those modeling problems. But if we were to do that, we would model 5/8 and then we would take away 2/8 from that. And even just seeing these on top of each other, or kind of visualizing those models, you would be able to see that you would have 3/8 left over. 5 minus 2 is 3 for our new numerator. And we don't do 8 minus 8 is 0. We have 3 out of 0. We just keep our denominator the same, 3/8.